It is challenging in a technical way, and for us every new request is actually a new challenge to find a way to meet the requirements. My name is Bartosz. I'm a research engineer at Center of Optics Manufacturing in TNO Delft. For us, every mirror is specific and complex. We are doing freeform mirrors. The shape of the mirror is defined by the function, and it is not spherical or parabolic. In our case, it can be very complex function that defines the shape of the mirror. So for this kind of the mirror, we need to use a dedicated equipment for measurement and also for manufacturing to be able to achieve specification requested by our customers. Magnetorheological finishing, it's a technology to polish or to finish mirrors. You have variety of different polishing and finishing techniques, and they can be used to correct the mirror shapes. What is specific for magnetorheological finishing, it is a tool that we can control in a very precise way. It's composed from polishing slurry and iron particles, and those iron particles are being injected to the head of the polishing machine and being exposed to the magnetic field. And because of this exposure to magnetic field, this fluid becomes temporarily solid and stiff enough to perform the polishing run. I think what TNO is doing and what we are doing as optics manufacturing is unique, because we are really able to manufacture high precision mirrors in metals. That is quite exceptional and difficult. We have a dedicated equipment to do that. Our colleagues are super highly skilled experts that can perform this job. Yeah, the level of accuracies and the material that we are using make us unique, I think.